We're continuing our consideration of various types of non-covalent forces operating between molecules, and especially those associated with water. We also want to get an idea of the relative strengths of these forces. Another type of non-covalent bond results from weak attractions of dipoles. Note that there is no net charge, so they are not electrostatic in nature. These are referred to as van der Waals forces, and there are three distinct types listed here, and which we will look at in turn. As the name implies, dipole-dipole interactions result from attractive interactions between molecules that carry permanent dipoles. The partial positive dipole on one molecule attracts the partial negative dipole on another. Note the examples illustrated here of water interacting with an alcohol molecule on the left and water interacting with a ketone group on the right. A permanent dipole in one molecule can induce the formation of a transient dipole in another molecule, causing a momentary distortion of its electron clouds. These types of interactions are weak and not especially soluble in water. Finally, two molecules may induce dipoles in each other. These are the weakest of the forces we've considered and are referred to as London dispersion forces, named after a German-American physicist. From the table given here, you can see a ranking of the various types of forces operating between atoms. It's not important that you remember the actual value of these bond strengths, only that you recognize their relative strengths. You might think that the strongest bonds are the most important, but we will see that the weaker forces have most to do with how biological systems function. Perhaps you can already start to imagine why.